All right, primary trig ratios. That is the topic of the day. So what do you need to do? You have to learn the terminology related with application and real world questions. And then you have to be able to use trigonometry to solve the problems. So let's get through the terminology. And there's not a lot of terminology. It's just these two terms off to my right, angle of depression, angle of elevation. It's the way I always draw it up. I got a person on a cliff. All right, and then I got some water down below. And I have my very stealthy Apache attack helicopter here. So you just see it, so stealthy and so cool looking. And then down below, we got this very complex battle cruiser. So here's my boat with the smoke. Okay. What we have here is the two terms fit in here. If you look straight out to the horizon, okay, that is our the horizontal. Okay, so it's the horizontal or horizon. Okay, so everything is measured from the horizontal. So if I was to look down at the really cool boat I drew, that no one's laughing at, and was to look at the boat, the angle that I make with the horizontal is our angle of depression. We have to shrink that to make that fit. So there we go. So the angle of depression is this angle right here. Okay, the angle measured from the horizontal line to the line of sight between the objects. So there is our angle of depression. So if a question says the angle of depression was, it means you're looking down. If I was to look up at the helicopter, that really cool military helicopter that I've drawn, we are looking at what we call an angle of elevation. Get smaller, there we go. So angle of elevation, and I'll kind of draw that line in there. So here's our angle of elevation. So that means you're looking up, an angle measured from the horizontal line to the line of sight between objects. So I'm looking up. All right, so that's the difference between the two. Look up, look down. And that is the terminology. So there we go. I know it's difficult to replicate my high-tech drawings. Anyone with any artistic talent, I already dislike you, but that's all right. You can still come to class. Example 1. Helicopter spots a campfire. Careful, don't touch it, it's hot. Okay, so there's my line of sight. So the helicopter spots a campfire at an angle of depression of 15 degrees. So angle of depression. So that means that if the pilot was looking out, straight out, and looks down, we have an angle of depression. So that's 15 degrees there. Draw a diagram and mark on the angle of depression. Woohoo! And the question. If only they were all this easy. All right, so just to finish this off, I'm just going to put this. So there's my horizontal line of sight. You don't have to do this on every diagram. This is just for the first one. And there is angle of depression. There you go. Example 1, finito. All done. All right. If you have any trouble with that one, if you want me to discuss it more in class, just let me know. All right, on to the next example. Caitlin looks up at an angle of elevation of 75 degrees to see the top of the CN Tower. Draw a diagram and mark the angle of elevation. Now again, very, very complicated. Okay, so here's Caitlin, in case you weren't sure which is which. And this is Tower. There you go. So if she looks up to see the top of that tower, there's her line of sight. We measure from the horizontal. Now, here's something with the word problems. 9 times out of 10, we are going to measure from the ground, but for argument's sake, the horizontal should be taken from the eyes, and that's where the 75 degrees is. Okay, so angle of elevation. So if you're not sure how tall the person is, the question probably wants you to take it from ground level. All right, so it's not going to make that huge of a difference. But if you're not sure, especially on a test, just ask. All right, 1, 2. Let's skip 2. Oh, there's one below. That's why I couldn't find it. Oops. So here we go. Let's do some calculations, hopefully, on this one. So a surveyor measures the angle of elevation from his eyes to the top of the tree. It can be 73 degrees. Now, he looks like a pretty laid-back surveyor. But anyway. He knows that his eyes are 162 centimeters above the ground. So here's the horizontal. So I know this distance is 162 centimeters. And he's standing 7 meters from the tree. Draw that distance on your horizontal, okay? It makes more sense that way. How tall is the tree? So you need to construct a right angle triangle here. We know the angle in here, I haven't drawn it in, is 73 degrees. So where is that missing right triangle? Well, the right triangle is right here. You use your line of sight. That didn't show up on the tree whatsoever. Okay. So I guess I'll just draw one on top. I have a green pen in my hand, that won't work. So here's the triangle. All right. So what do we want to know? We want to know the remaining height of the tree. I'm going to mark it as an X. To solve these problems, you have to label the diagram. Have to. So this is going to make a right angle. So across from the right angle is my hypotenuse. Angle is given. So this is my opposite. And the last side is the adjacent. Here we go with SOHCAHTOA. So again, I'm going to scroll it on here. SOHCAHTOA. Okay. All right. What information do we know? Well, I'm looking for opposite. All right. So that's over here. I'm looking for the opposite side. So it could be sine. It could be tan. Don't want to ruin the surprise for you, so I'm going to hang you out a little bit longer here. We know the adjacent, so we know A. So that means it could be cos or it could be tan. Hey, I know everything about tan. I'm going to use tan. Okay? That's how it works. Process of elimination. So tan theta equals opposite over adjacent. Please note the notation. I want to see this for full marks. So tan 73 equals, excuse me, opposite is X, and the adjacent is 7. Do not calculate tan 73 to 4 decimals. Hold on. I'm going to multiply both sides by 7. Okay, or you're doing the partial, cross multiply, whichever way you're going with this. Hopefully either way gets you to 7 multiplied by tan 73. Now for those people that are calculator maniacs, you can now go ahead and use your calculator. But at this point, you have a level 4 because I marked that process. It's the process which is important here. So pull out the calculator. 7 multiplied by 73 tan would equal 22, we'll call it 22.9. Keep my life a little simpler. 22.9 meters. Is that the total height of the tree? Hopefully some people are saying, no, don't do it, don't do it. And you're absolutely right. We need to go one more step because we are given the height of the person. All right. So I'm just going to go total height equals 22.9 plus, now it's in centimeters, this 162. So that's 1.62 meters. So I'm just going to add that on there. So we end up with a 2, a 5, a 4, 24.52 meters. So therefore, the tree, therefore statement, very important for communication. The tree is 24.52 meters tall. Okay, so all goes toward your communication mark. All right, so there it is. Okay. Yes, you have to do absolutely everything that I wrote on the left side here. So where's my highlighting pen here? Here we go. This is a requirement. I have to see this in grade 10. I need to see process. And like I said, by the time you get to the third line, you have full marks if you're correct. Okay? I also have to see this diagram. Now, are you going to have as much stuff wrote on as I do? Of course not. trying to highlight and point to things that you can't see my hands, because if I point to the board, you can't see my hands. So please keep that in mind. You do have to label the triangle, or you do have to draw a triangle. All right, moving along. Final example, the guy wire. I don't know why it's not a gal wire, but the guy wire is this wire right here that touches to the ground. Okay, the one that almost takes your head off when cutting line. It holds the hydro pole in the upright position. It's attached to the pole a ½ meter from the top. Okay, so ½ meter from the top, so that distance right there is 0.5 meters. Makes a 63-degree angle of elevation with the ground. Okay, very careful there. 63 degrees with the ground. So you need to find where the wire and the ground meet. And if the guy wire is 6 meters long, how tall is the pole? So we are looking for total height here. And from the right angle triangle, we're going to be able to find that measurement right there. So, got to see all that on the diagram. That means this is my reference angle. I'm going to assume the pole is properly installed. Makes that my hypotenuse. That's my opposite. That's my adjacent. Where's my SOHCAHTOA? SOHCAHTOA. There we go. So, what do I do? I know the hypotenuse. So I'm either using sine or cos. So TOA off the page because it's got no H. I want to know O. There's my winner. Ding, 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 ding. So I'm going to use sine. So I need to see sine theta equals over H. Sine 63 equals x over 6. So I need to isolate. So either I'm going to say, oh, 6 is dividing x. The opposite is multiplying. Or it's a partial multiply, or partial cross multiply. But I do need to see this step right here. 6 multiplied by sine 63 equals x. And like I said, by this point, you have the majority of your mark. Pull out the old calculator. 6 times 63 sine equals 5.3. 5.3 meters. Is that the total height of the pole? Of course not, because you're saying, hey, don't forget about the 0.5 there, teacher. So total height. Total height is equal to 5.3 plus the 0.5, which brings the grand total to 5.8 meters. So therefore, the pole is 5.8 meters tall. Yay! And there we are. Okay, so there's all the steps that you need to show for these word problems. They don't get a whole lot more complicated in the grade 10 course that we're kind of reinforcing this skill. If you have any problems with the word problems, though, I'll more than gladly sit down with you and we'll go step through them. All right, make sure you're checking the answers in the back of the book. Make sure you understand what you're doing, not copying from your neighbor, since it'll show up when you have to do the individual assessment. All right, we'll see you next day in class.